So hello everyone, it's my homework 2, zhalgas tuyakbay, and today we're gonna solve the first exercise. It's exercise number 5 from the 5th chapter. So what we see, define the sequence a1, a2, and 3 and etc. by a1 is 0, a1 is equal to 0, and a2 is equal to half, and a k plus 2 equal to half multiplied by a k plus 1, and the k must be more or equal 1. So first of all, we must find the first 7 terms of the sequence and then prove that this equation for every n more or equal for 1. So let's find the first 7 term. So we already have the a1 and a2, and if we look at the formula of the sequence, we see that, for example, a3, this is a1 plus a2 divided by 2. Арифметически середина получается. So then we can find the a3. a3 is equal to 1 divided by 4. Then we can find the a4, and 4 is 3 divided by 8. Yes. Then a5 is so a divided by 5 is 5 divided a5 is 5 divided by 16. a6 is 11 divided by 32, and finally a7 is 21 divided by 64. So we have something like that. We have a 0, we have 1 divided by 2, we have 1 divided by 4, we have 3 divided by 8, we have 5 divided by 16, and 1 divided by 32, and 21 divided by 64. So if we look at this correctly, we can say that for example a3 and a2, if we take like this, a3 minus a2, there is minus 1 divided 4. If we take a2 minus a1, it's 1 divided 2. Let me. Okay, so in other words, we can say there that, for example, these two pairs, if we minus these two pairs, this is 1 divided 2, then this is minus 1 divided 4. If we take these two pairs, we take 1 divided by 8. If we take these two pairs, we take the minus 1 divided 16. So that is our like a formula. This is a basic geometric progression. So then we can say that ak plus 1 minus ak, it's minus 1 divided 2 power of k, and say that like an it's a1 plus a2 minus a1 plus a3 minus a2, and just replace. It's 0 plus half minus 1 divided by 4 plus 1 divided by 8 minus 1 divided by 16, and tilde minus 1 divided 2 and minus 1. So it's a geometric progression. Then there is a simple solution. We have b1 there. b1 is equal to 1 divided by 2, and the q is 1 divided by 2 but minus 1, and the number of members is n minus 1. So we have a simple formula like s equal to b1 multiplied 1 minus q power of m divided by 1 minus q, and just replace that. an is equal to 1 divided by 2 multiplied 1 minus 1 divided by 2 power of n minus 1 divided by 1 minus 1 divided by 2. So if we calculate this, if we take a solution from this, we can get something like that. an is equal to 1 divided by 3, 1 minus 2, or minus 1 divided by 2, and minus 1. So we prove that is equal to this one for every n more or equal to 1. This is the fifth, the 5th exercise from chapter 5. So there is the second exercise from chapter 5. This is the sixth exercise. So solve the recurrence relation an equal to minus 5 a n minus 1 plus 6 a n minus 2, and then n more or equal to 2, given the a0 is 5 and a1 is 90. So then first of all we need to create some formula. So we have something like that. First of all, a n minus 1 plus c2 a n minus 2 equal to 0. There we replace the an for r quadrat, and все в одно собираем. So we have an plus 5a and minus 1 minus 6a and minus 2 equal to 0. Then we replace the an for r quadrat. Then we have the r quadrat plus 5r minus 6 and 0. If we take the solutions from the theorem of Yates, we can say that there is the R1 is 1 and R2 is minus 6. So let's write solution. Like it's not equal to each other, so an is c1 r1 power of n plus c2 r2 power of n, and just replace like it's c1 1 power of n plus c2 minus 6 power of n. There we can see that doesn't matter what's the power of 1, is always 1. Then we can write this as c1 plus c2 multiplied by minus 6 power of n. So just replace like this. For example, if n equal to 0, this is c1 plus c2 minus 6 power of 0, it's 5. So then it's 5 equal to c1 plus c2. Same thing with the other one, like if the n equals to 1, it's c1 plus c2 minus 6 power of 1, it's 19. Then it's equal to c1 minus 6 c2. So we have some system like c1 plus c2 is equal to 5 and c1 minus 6 c2 is equal to 19. From the one, let's reject second equation. Is gonna be the 7c2 equal to minus 4c and c2 equals to minus 2. Then c1 is equal to 7. And just let's write down the answer like an equal to 7 minus 2 multiplied by minus 6 power of n. It's our answer. So it's next exercise number 6. There we can see the exercise. In a group of 82 students, 59 are taking English and 46 are taking maths, and 12 are taking neither of these subjects. How many are taking both English and maths? So we have 82 students and the 59 is learning English 46 is learning maths, and 12 is not learning. So the first step, we must find the students who learning something. It's 82 minus 12, it's equal to 70. Then so if we just add both of them, like English and math, 59 plus 46, there is gonna be 105 students, but we have only 70 students, and there is 35 students more. Why? Because some students who learning both of subjects, they're counting twice. Then because they're counting twice, it means that they're learning two subjects at one time, something like that. I don't know how to explain that, but it's the basic logic, logically like thinking. So the answer is 35 students learning both of subjects is answer for A. And then B. So there it says that in a group of 97 students, the number taking English is twice the number taking math. 53 students take exactly one of these subjects, and 15 are taking neither course. How many students are taking math and how many students are taking English? First of all, let's reject the students that not learning at all. Like 97 minus 15 is gonna be 82. Yes. Then let's just take students who learning only English as X, and take students who learning only math like as Y, and students like who take both of these subjects, let's take it like B. Then we have that X plus Y plus B is gonna be 82. So there it says that 53 students take exactly one of this subject, so it's gonna be X plus Y, it's equal to 53. Then our B is 29. So the students who learning only English, it's X plus 29, and the students who learning only math is not only just learning the English and learning the maths, it's Y plus 29. So there is says that English, the number taking English is twice the number taking math. Then we can say that X plus 29 it's equal to 9 multiplied Y plus 29. Then from this we can take the X minus 2Y, it's equal to 29. Then we can create a system like x plus y, like 53, x equal to 53 minus y. Then if we calculate all of this, we can get that y is 8 and the x is 45. Then we just replace it. Давайте здесь напишем. So we have 8 plus 29. It's members who students who are learning math, and x plus 45 plus 29. It's 74. It's who's learning the English. So it's more twice, and yes, this is the answers. So this is the nice our problem. Let's try to solve it. So the owner of convenience store reports that of 890 people who bought bottled fruit juice in a recent week. So we have the orange, we have the apple, and we have the grapefruit. Let's take it slightly, and citrus punch. So if we calculate all of these numbers, it's gonna be 1,300 people. So the first question is all 4 kinds of juice. So if we open the calculator, take like this is all of people who like in the условии we can see that there are the 890 people, but 1,300 people is more than that number. It means that we calculated twice or 3-4 times that people who bought 2 or 3 juice. So what is it means? We calculate at first the number of people who take 2 juice, like this is gonna be, if I'm not wrong, minus 441. So, and we add the people who bought 3 juices. It's gonna be the it's gonna be the 32. So there is 891 people, but we have only the 890 people. It means that one more people is that people who bought all of this juice. So it's A is gonna be 1. Next case, grapefruit juice, but nothing else. So, okay, but at first let's calculate the case. There is more than 2 kinds of juice. So So if we take that one people who both all kinds of Jews, it's 1 plus the 3 peoples who both are 3 juices, but in these cases that one man who both all 4 juices includes 2, so we minus 1 and add to this. It's gonna be 3 16 8 plus 1, and it's gonna be 29. So the B case, the grapefruit juice, but nothing else. At all we have the 100 people who both grapefruit juice, but in 100 people we calculated people who both 2 juices like twice and 3 juices or all juices like 3 times calculate. So for calculate correctly, at first we take from this 93 people, it's all people who both grapefruit juice with other juices. Then we add the number of people who only buy 3 juices is 28, and minus 1 is that on people who both all juices, and it's gonna be the 22. Yes, oh I'm sorry, 34. Yes. And let's look at the C case that says exactly 2 kinds of juice. So if we calculate only people who both 2 juices, we can get that number. But there is people who both more 2 juices, for example 3 juices, and the number of people who both 3 juices is 28, and we multiplied 2 by 2. Why? Because they're replying in this, for example, juice and apple and juice and grapefruit, like 2. Ну, они повторяются. So then we and also that man who both all of juices we multiplied by 3. And it's gonna be 382. 382. Yes. So next exercise. How many integers less than 500 and relatively prime to 500? So in case A, we use the formula of Euler. It's gonna be this, like this. 1 minus 1 divided by P1 multiplied by 1 minus 1 P2 So what is the 500? 500 is 5 multiplied by 100, that is 5 multiplied by 10 of power 2, and we also can open this as 2 multiplied by 5 power of 2. That means that 5 multiplied by 2 power of 2 multiplied by 5 power of 2, that means that 2 of power 2 multiplied by 5 power of 3. So it's prime divisible numbers of the 500, and if you just replace to the Euler formula, it's gonna be the 500 equal to 500 multiplied by 1 minus 1 divided by 2 multiplied by 1 minus 1 divided by 5. So if we calculate these things, it's gonna be 500 divided by 2 multiplied by 4 divided by 5. It's gonna be 100. It's gonna be 50 multiplied by 4. It's gonna be 200. So there is a 200 numbers of the prime numbers are relatively prime to 500 and less than 500. So the B case, there is a number 9975, and we also must find the prime numbers multiplication. So this number ends of the 75, and it means that it's divided by 25. If we divide by 25, it's 399. So if we add 399, it's gonna be 21. 21 is divisible by 3, so it means that this number is divisible by 3, and it's gonna be 133. And we take just 2, 3, 5, and if it's not divisible by 2, it's not divisible by 3, it's not divisible by 5, 7 is divisible by 7, it's 19. So 19 is a prime number, and it's gonna be 3, 7, 19, and 5 of power of 2. And we just replace the Euler formula, like it's gonna be multiplied by 1 minus 1 divided by 3 multiplied by 1 minus 1 divided by 5 multiplied by 1 minus 1 divided by 7 multiplied by 1 minus 1 divided by 19. And if we just calculate with a calculator, it's gonna be the 4320. It's case B and it's case A. So the next exercise, in how many ways can 12 players be divided into 2 teams of 6 for a game of street hockey? One team to be called the good guys and another the bad guys. So the main point of this that это различимые first. If one player, for example, the player A is joined to good guys and player B is joined to the bad guys, it's one moment. And if the player A joined to the bad guys and player B joined to the good guys, it's another point. So for example, at first we must take the 6 people from 12 for the good guys. So it's gonna be like this. It's equal to let's go to and gonna be 12, and if we just calculate it, it's gonna be 924. Then the left 6 people automatically join to the bad guys, and the ways to choose there is like 366, and it's just 1. So 924 multiplied by 1 is gonna be 924 is the answer for the A case. So the B case. Теперь the good guys and bad guys have not the name, and это неразличимые. So there is gonna be, we just delete the duplicate, like we have the same thing but divide by 2, so it's gonna be 4062, because if they're joined to the first team and second team and just change the position, is gonna be one context, and we just delete the duplicate by divisible by 2, like, yeah, it's gonna be answer to the B part. So the next exercise, how many different signals, each consisting of 7 flags arranged in a column, can be formed from 3 identical red flags and 4 identical blue flags. So the main points, it's identical, and then we just must take 3 position from the 7, and the how we can get it, we get it from like as this. So it's 7 factorial divided by 3 factorial multiplied by 4 factorial. If you calculate this, it's gonna be the 35. So, and the left 4 position for the blue flags is automatically 1, because we have only one context. When we put 4 from 4, it's 1, and 35 multiplied by 1 is gonna be 35. So so next exercise, a new corners club of 30 people wants to choose an executive board consisting of president, secretary, treasurer, and 2 other officers. In how many ways can this be completed? So the important moment, 2 other officers, то есть это неразличимые. President, secretary, treasurer, это различимые. So it's gonna be two combinations. So first of all, we should choose the president, and for president we have the 30 people of choice. Then we should choose the secretary. For secretary, left only 29 like seats, like peoples who we can choose, because one of them we already choose. So 29, and same as secretary we choose the treasurer, 28. So if we calculate this, we have the 24,360. Then we gonna calculate the two other officers, and это неразличимые, еще раз повторяюсь. We can calculate it just from the formula, like 227, because 3 people from the 30 people we already choose. It's gonna be 27 factorial divided by 2 factorial by 2 factorial and multiplied by 27 minus 2 factorial. If we calculate all of this, it's gonna be 351. And for calculating all the situations from the first combinatory and second combinatory, we must just multiply each other. Yes, and it's gonna be 8,550,360 ways to choose president, secretary, treasurer, and 2 other officers from the 30 people. Yes. So the last exercise. A group of 8 scientists is composed of 5 mathematics and 3 geologists. In how many ways can 5 people be chosen to visit an oil rig? So it's very simple, because it's not it's неразличимый. It doesn't matter of proportion of the peoples who we choose, and we just take the formula as C5 8, and that's gonna be 8 factorial divided by 5 factorial multiplied by 3 factorial is gonna be 56. It's answer to the A case and the B. So suppose the 5 people chosen to visit the rig must be comprised of 3 mathematicians and 2 geologists. Now, in how many ways can the group be chosen? So there is our choose is divided by 2 not independent like parts. Then the answer of these parts we just calculate like multiplication, and that's it. So first of all we must choose the mathematics from the 5 members of group. It's 5 factorial divided by 3 factorial multiplied by 2 factorial, and it's gonna be 10. Then we must choose the geologist. It's from 5 to it's gonna be it's from 3 to it's gonna be 3 factorial divided by 2 factorial multiplied by 1 factorial, and if we calculate this, it's gonna be 3. So we just multiplied each other to find all situations, and it's gonna be 30, and its answer for the for P part. Yes. So that's all. Thank you for watching, for attention. Goodbye.